Today we're going to talk about pH calculations. Before we talk about the calculations, we need to talk about what pH is. So pH is a measurement of how many hydronium or just H plus ions there are in a solution. So the lower the pH means that it's acidic. And by low, I mean less than 7. When we hit a 7 pH, that means that the solution is neutral. It's neither acidic nor basic. If you have a high pH, it is a base, and by high I mean greater than 7. Now we have constantly heard the word pH, but we don't usually hear about the word pOH. pOH is a measurement of how many hydroxide ions there are in a solution. So this is the complete opposite measurement. So here if you have a low pOH, it's a base, so that is less than 7. 7 for pOH is still neutral. And then a high pOH is an acid, and that's when it's greater than 7. Now there's a few different equations that we can use for calculations. Now some of these relate just the two that go together, so pOH and hydroxide, or pH and hydronium. But then the two, pH and pOH and hydroxide and hydronium, can be related as well. So first, if we're trying to solve for the pH, we are going to take the negative log of our hydronium concentration. Now, if we're trying to find the hydronium concentration, they have to give us the pH. So we have 10 to the negative pH. That's how pH and pOH are related. pH and hydronium are related. Now, if we're trying to find the pOH and they give us the hydroxide concentration, we have to take the negative log of hydroxide to get our pOH. If we're looking for our hydroxide concentration and they give us our pOH, we take 10 to the negative pOH. Now, what happens if we want to figure out information on both sides of the spectrum? Well, pH and pOH are related by when you add the two together, you get 14. So if you're given pOH and you're asked for pH, you can just subtract 14 from, or you can subtract pOH from 14. Now, this is a more difficult equation, and you can completely avoid this equation if you'd like by using the other 5. But if you would like, you could use 1 times 10 to the negative 14th is equal to the concentration of hydronium times the concentration of hydroxide. That's how hydronium and hydroxide are related. Now, here we have hydronium concentration and OH concentration. Those brackets mean concentration. They're not always going to give us hydronium and hydroxide. Sometimes instead they'll give us the name or formula of an acid or a base. So if they gave us the name or formula of an acid, okay, and they tell us the concentration, they're really saying that that concentration is hydronium. Over here, if they give us the name or formula of a base, then they're really saying that that concentration they're giving us is going to be of hydroxide. Let's try a few example problems. So here it says, what is the pH and pOH of a solution with a hydronium concentration of 9.34 times 10 to the negative 6 molar? Well, if we look at our formulas over here, we are being asked for the pH and pOH, and we're given a hydronium concentration. So our pH equation is equal to the negative log of hydronium. So that would be a good place to start to solve for our pH. So pH is going to equal the negative log of our concentration. So if we plug that into our calculator, you have to be really careful plugging this into your calculator. Make sure you use your parentheses appropriately. We will get a pH of 5.03. And we need our pOH also. Now pH and pOH are related through this 14 is equal to pH plus pOH. So in order to get our pOH, we're going to do 14 minus the pH we just solved for. That's going to give us a pOH of 8.97. let's look at this next question. It says, what are the hydronium and hydroxide concentrations of a solution of HBr that has a pOH of 12.4? So what we first have to figure out is HBr is that an acid or a base? We have a hydrogen out in front, so that tells us that this is an acid. Okay. Now it has a pOH of 12.4. If we know our pOH, we can get our pH also. Now the reason why we're going to be solving for pH as well is because we're solving for hydronium, which is related to pH, and we're solving for hydroxide, which is related to the pOH. So if we figure out our pH and pOH, then we can just use our equations. So if we have our pOH, we're going to solve for pH. We're going to get 1.6. So that's our pH. Now if we look back at our equations over here, hydronium concentration is equal to 10 to the negative pH, and hydroxide concentration is 10 to the negative pOH. So now all we have to do is raise our pH to the exponent and our pOH to the exponent to solve for each. So for hydronium, we're going to use 10 raised to the negative 1.6. That's going to equal 0.025 molar. And then for hydroxide, we're going to do 10 to the negative 12.4. That's going to give us 3.98 times 10 to the negative 13th molar. Now if we think about these, HBr is an acid, so it makes sense that we have a much larger concentration of hydronium than we do of hydroxide.